Hello there, it's Heider here. Nice to see you again. Thank you for watching my YouTube channel. If you're on this far on my videos, then probably you might have watched the previous videos that I've made, and I hope you might like them at some point. So yeah, today's video is going to be more on the SYSBIOS side. We did, I think, the last video we did yesterday on the output side, on how do we switch the pins on. So if you see on the the picture behind me at the moment, you'll see all the 4 lights going on and off, and also what we did as well, we have the which lights actually switch on or off. So basically, as I said yesterday, this is the index of the lights being switched off. So when you define something in the array, you'll have starting index of 0, and then so 0, 1, 2, 3 is the lights we are talking about. So yeah, and so now, as you can see, we defined the output pins, and that they all working fine. But a very important part of the videos that I don't know if anyone noticed or anyone might have wondered. If you remember yesterday, just going on to the code here at some point, what we did, we went on, by the way, some of the private messages I received asking about increasing the font intensity. So what I did, I actually did exactly that. So I put a little darker font on this, so now you can see, or hopefully you can see better. Anyway, so on the main function, what we did, we initted the board, we init the GPIOs, and we print something on the UART, and here we entered an infinite loop on so here is the first part of the loop where it says switch the 4 lights on, delay of 5, and then switch wait for 10 or twice as much, and the other loop is switch the lights off, one by one, and then wait for 10. Now this is what we did in a nutshell, but the problem is the delay function, and I'm just going to get back to this one. So before we carry on, I would really like to kind of take that bit out, this whole light on off thing, and make it into a function by itself, and you'll see why in a minute. So if I'm going to go here and I'm going to say void, let's just call them blink, or let's just call them ripple LED ripple. Yeah, LED is fine, yeah. Let's do this way, why not? Yeah, and here what we're going to do, we're just going to call that function from this side, yeah, and we are taking its code to that side. So really straightforward, really simple. So what I've done is I've got the main function now nice and clean. And what that means is, I've got a printf beginning, initialize the stuff, print on the UART the serial port, and then do the ripple. This function will never return because LED is going to just kind of run something called in blocking mode, so basically it's going to take forever, it's not going to stop. And the ripple of the LED all goes here. So let's just compile this one more time and run it before we carry on further. And I will explain the issue that we have with the system, and what is the cause, and what I'm going to work on in a very shortly. Notice the board is flashing 1, 2, 3, 4, and which is quite nice. Loading up, and now you see UART routing on serial now, so that's working. So yeah, so nothing changed. Yeah, we're just flashing lights back and forth, as you can see. Now the problem is this delay, right? I don't know if you noticed before, but what we tried to do, or if you really think about it, this 5, what does that 5 mean? Is that millisecond? Is that second? Is it minute, hours, days? It's really unclear, because that 5 is, you can tell here we are running about what, maybe 200, maybe 300 milliseconds from between each line and the other line. So it's not really, it's not 5. It's just a number. The reason for that is because on the delay function itself here, what we did, we just went into a loop, so a couple of loops. So this loop will count from 0 to what was it, 100,000? That's probably a million, isn't it? Yeah. So from 0 to a million, and this thing will ask it to count. So this is, so number 5 here means, so 5 times million. So 5, we counted to 5 million, and this is what caused this thing to wait. But that is incredibly inaccurate, and this is a really bad way of doing things, and it's not something I would call proper programming. The main thing is that we needed to do this rather than using the different delay. I'm just going to now show you this. There is a built-in function to relax the CPU and run it, get this into the background or the idle thread, and then carry on this way. So this is OCL delay we tried last time, and I'm just going to say duration here. So this will take duration and feed it into here. What we're going to do, we're going to remark this whole delay code, right? And now this duration should be milliseconds. Yeah, and that's how the OCL delay is. So if I go down in here and I change this to 5,000, let's say, sorry, what this is to 500, half a millisecond. And in here we're going to do another 500, and in here let's say we'll wait 1,000, which is 1 second, and here is 1 second. So in theory, if everything goes well, then my thingy, or my loop between each line and the other, should take half a second between each line and a line, and 1 second between the let's just say 2, yeah, not 1 second is fine. So if I'm going to compile it, watch what's going to happen. Yeah, see that? Notice the lights. Notice the lines in here. You just really can't catch them. They're so fast. What the hell? What's going on? And the lights, you can see them blinking. That means they're going as fast as possible. That means this delay function isn't doing anything at all. And this is where the problem is. Now, why is that? OCL delay is a built-in function to do delay, but it's just not happening. Why do you think that is? And also, if you remember the video before, what we did when we did the init board, what we said is that, where's it gone here? We said is the init module clock, we need that there because we wanted to have a consistent clock counting. Looking at this, the clock is actually a mess. It's just not working, nothing is happening. And pretty much if I leave it there, probably, or likely the OMAP or the CPU will probably start to heat up or burn more power and that sort of thing. Well, really, this is not something you want. And I don't want to go back to the for loop and stuff. Why do you think that is? The reason for that is because we are not, although we told the system that we are using RTOS and we are using SYSBIOS, but sorry, let's just rephrase that, or we are utilizing the SYSBIOS libraries and header files. However, you still haven't used SYSBIOS yet, and this is because at the moment we are telling the board to config, we're telling it to do stuff, but on that front we're not really, something is missing. So the board isn't really, the clocks aren't really right, and this is where the problem is. So now today's video we are going to talk about the SYSBIOS, and we already configured some of it, but we haven't really done, we haven't noticed anything different. It's just basically we copied and pasted stuff, and we went onto this bit here, we just added some things, and we did the var, and we did all the stuff, all the wonderful stuff that we wanted to do. So we said we wanted to use all that stuff, we said we wanted to use this, so define these variables, we wanted to use these things. Now all that stuff give you libraries, but that's not what SYSBIOS is about. The problem is, at the moment, when looking at this code, you are really not using SYSBIOS yet. Now, to use SYSBIOS, you would have to do the following. So what you have to do is init, BIOS, I beg your pardon, BIOS. This is how your system will work. So what that means is everything will be initialized nicely, and then you're going to go back to the BIOS, and the BIOS is going to power up itself, and then from that power up itself, the BIOS will take over, and it will start to, you know, synchronize stuff, run the tasks, and do all the wonderful stuff that you cooked on the GUI a minute ago. Obviously, that's not going to work by itself because that's a BIOS function, and what you need to do is you have to include this you have to include it here somewhere. So what I'll do, I'll just put the include to the first thing to begin with, and I will say, so we need the BIOS there somewhere. So C, where's it gone? TI. This one is not going to be the PDK. We are looking for the BIOS here, and it's the TI. Here it is, this BIOS, and we should be an H file here somewhere, and it's bios.h. Yeah. So we are doing, yeah. So TI SYSBIOS / BIOS.h. Okay. So now what's going to happen is what we're going to jump into. This is a header file. And on the main function, it's just going to power the BIOS up, and after this thing, you're not going to get anything continuing from here on more, because now the BIOS is running. Equivalent to Intel running something called in protected mode. I don't know if you know about protected mode. Protected mode is you switch to it, and the whole thing, the BIOS or the CPU, changes the behavior and start, you know, using the CPL and DPL and works things differently. So yeah, let's run the code and see what happens. I used to develop a lot on Intel and protected mode stuff. I even wrote my own OS. I called it OS 48, and I wrote debuggers and all that kind of stuff. It was all personal. I never published any of it online. But I always loved Intel. And this, I think, with the capabilities of this CPU, I really like the future of it. So what's going on? Why is that error there? Oh, what's happening? I've had this before once. It's probably a little bug. What happens is it just keeps going on with this message on and off, and I don't know why that happens. So I'm probably going to kill the thing and start it again. Just waiting for that. Yeah, just going to kill it. Interesting. Yeah, close the program please, thank you. Yeah, the platform is based on Eclipse. So I'm just going to run this again. That's my son, by the way. It's really chucking so much stuff on the serial port, and you know, lights are going crazy at the moment. You know, interesting. Sorry. You can press the right button to speed up or skip 10 seconds each. one more thing to do actually. I would rather, because I have OBS running on 4 threads, I want that to be running on 4 threads too, because now it's going to take the CPU and it's going to slow things down massively, and I don't want that. First of all, let me just tell this to, just going to stop the this one for a bit. So on this side, yeah, so OBS is taking, oh, it's taking all CPUs. No. Why is that? I want you to only do 4 CPUs, that's OBS, and I want CC Studio to do the other CPUs. I just stop there. Let me catch it there, hold on. Yeah. So, set affinity, we're doing the last CPUs. That's definitely why we're having this system is so slow, running like a dog. So now we are back online, we should be having it fast, hopefully. And yeah, we should be up and running. So now this one, yes, now we're getting responses, so just leave it there, it's fine. Yeah. Good, so now CC Studio should come up any second. And I'll stop this for now, just a second. Just to give, let me clear the screen as well. Clear the scroll block. Yeah, so now we're waiting for this to happen. I probably will speed up the video at some point. It's taking a long time, shouldn't be. Oh yeah, here we go. You got a window? Thank you very much. Okay, good. So, yeah, that's probably because OBS was taking all threads to record this stuff. Now we're back on business. We're back in business, sorry. Yeah, okay, now, let's close that window up. Yeah. So, if I, just going back to what we did before, and I'm gonna, as it is, no changes, just going to deploy it again. And whilst we're doing that, I'm just gonna reconnect to Serial.com 3. And we should see that running, you know, quite nicely. Oh, was it COM5? It wasn't COM3. It was COM5, wasn't it? COM5. Yes, that's it. That's the one. So COM5 is what I'm seeing here. We are compiling here 7%. Oh, got an error. I don't see why. Unresolved symbol remain. What's the unresolved symbol? No, stop. Yeah. Okay, let's have a look. Symbol file, here we go. BIOS init. Yeah, they should work. Let me check something. Hold on. yeah, sorry. It's sorry, that's my fault. It's BIOS start, not init. BIOS start, yes, sorry. And we will power up now. Yeah, stupid mistake. But this should work now. Yeah, we're linking, very good. Good news. Wonderful. And now I'd expect to see the serial to stop and the light also to stop as well. Oh, do I have, sorry, it's doing the LED ripple. It's not going to stop because it's jumping back to the function. Ah, sorry. Sorry. Yeah, okay. What's happening is we are running the function, the LED ripple there, before the BIOS start, which is dumb. Sorry, let's just do it this way. And yeah, now I'm going to start the BIOS and remark this function and do it again. Sorry, I probably will skip this whole section. Just to recap, now we are starting the SYSBIOS now, using BIOS start function. When you start that, it'll jump into the SYSBIOS framework, and this whole thing will work. I expect the serial to stop chucking stuff and the lights to stop working. Or these get frozen at whatever status they used to be. Come on. Waiting. Yeah, loading program. Yes, there we go. Exactly. So now what we have, let me check. No lights, as you can see, come up, and we have the thingy says system main started, and also we have new UART working serial now. So what that means is, forget that NW. NW means it's trying to type something, but it went into here. So anyway, so UART working serial now. What that means is the program started. It did this, it did that, it did this, it did this, and it did this, and that's it. Nothing happened. We didn't tell the system to do anything else since then. Now watch if I enable that after. What's going to happen? Or I'm just gonna spell it out for you so you know what's happening. You can read what I'm typing. This line should never be displayed. And similar thing, just in case you don't see it on the UART. This line should never be displayed, and this function should never run. And I'll show you why. So if I run it there, should be quick now. So clear the screen, just a second, clear the scroll block. Yeah, and now we should see, there we go. So UART working serial now, main started, and that's it, the system ended. It didn't really end, it's just the SYSBIOS now taking over, and now the system is running its stuff. Call it in protected mode if you like, or the Intel protected mode, if that makes any sense, or if you are doing an Intel programming like me. But this is what's happening right now. So how do we get the system to run these things? Well, going back to the SYSBIOS now, and this is what we need to kind of pick up. Just waiting for that to load. If you remember a couple of videos ago, we have defined all the stuff in here. So we said we want BIOS, we want cache, we want clock, we want defaults, we want blah, all that kind of stuff. And pretty much, we haven't used all, well, we hardly use any of it. And this is where things, this is where a huge difference goes between this system and the Arduino system, or the basic ones. The reason, because now you got a really, you know, you're entering a different world from this point. You are looking at, for example, Arduino, you have a setup function where you set things up, and a loop function where things will just gonna run the loop. If you want to do anything else, or a different function, or have a different function, a different looping thing, you can have to call each other, and everything runs in serial. And it's nice. It, you know, can do LED flashing up stuff, or motor stuff, but this is different. This is a multi-threaded, multitask system, and it's got a lot of interrupts, got a lot of memory stuff. It's got a lot of something called inter-process communication, ISL. So now what we're going to do, we're going to start our function, our LED counting thing, using the SYSBIOS now, and the SYSBIOS is going to take over, and you see the difference. So to begin with, I'm going to go into task, right? And the task in here, you'll see it's not really much. You'll see, for example, number of priorities 16, blocked function. If something is blocked, it's actually chucked in there. You can define a function in here. Default stack size 2K. It's enough, I think. You don't need to do more. We're going to do a lot of stuff there. You know, there's a lot of things, and what we are interested in is clicking on the instance in here, and now add. Notice we said 16 instances we can do, or 16 tasks we can do, or 16 priorities if you like. So what we'll do, we'll just define one for now. Yeah, and what we'll call that, for example, let's just say LED flash. I just call task, or TSK LED flash. I like this. Yeah, or task, if you like. Oh, sorry, the handle, I beg your pardon. LED flash, and the function, I'm going to call it TSK. I'll just call it. You know what? Let's just keep it simple. I'll call it the same. I usually do TSK and then the function name, so I know it's a task and it's powered up somewhere else. That's fine. Priority, obviously you can go between 1 and 16. You can, 1 is higher, 16 is lower. So this is not going to matter for now. I'm just going to have this one or maybe 2 functions to run on. And that's, I think, it for this function. And if we just save, and I'm going to copy yeah, that's fine. So LED flash, just wait, yeah, good. We'll copy this, and going back to the main C now, and you remember this guy here, the LED ripple. What I'm going to do is I'm going to say void, okay, and that's my LED flash function, and the function can take arguments, so UARG, yeah, and I can say A1 argument, let's just go argument C, argument 1, and UARG, let's just say arg1 and arg2. This here is a standard the argument stuff, it takes 2 arguments in there. So basically what that means is when you're back in here and you wanted to say, for example, I wanted to pass a value of 1 on the first argument and a value of hello to the second one, it will go to the arguments in there. So yeah, we're not doing that, and so if I undo this, right? I did it in silent priority. Anyway, that's fine. Yeah, so let's just put 0 and 0. Okay, so we're not passing anything to it. Yeah. And so now the LED flash. And in the LED flash, what I'm going to do is call my function. So, and that's exactly why I kind of isolated it. So if I do LED ripple, it's getting a little bit more complicated, or more, it needs a little bit more care. And what I mean by that, we have LED flash and LED ripple, and people, when they look at this, thinking what the hell's going on. So I think it makes sense to go back to the SYSBIOS bit, and I'm just going to call it task LED flash. Yeah, I think this makes sense when people, you know, read it. So yeah, and that is basically it. So this guy is going to call LED ripple. LED ripple is going to stay doing this forever, and we'll get. So now, if you remember, so without changing anything on the LED ripple, I'm just going to run this again and see what happens. And you'll see the difference now. Remember, we did half a millisecond between each line and the other, and 1 second between the on and then off. It's taken a little bit while. You can just skip this. I don't know if I'm gonna skip my video, speed it up at some point. I'll probably keep it as it is. It's not too long anyway. 33 minutes. You're seeing now it's taking longer to link and compile, because now we're telling it to use the task, and now the task is doing some stuff, and it's all doing stuff in the background. You know, you can do this programmatically without using any of the SYSBIOS thing. It's called the bare metal way of doing things, but I think this one really makes sense, because obviously you just go back to the GUI, check what tasks you have, and then carry on this way. Should say linking soon, or deploying soon. Yep, finished building, good. Linking, beautiful. Build finish, very nice. Now you'll see the big difference. There we go. See that now? That's exactly what we initially intended to do. Now, if you do count between every line and the other, or every one that says on to on, you'll see half a millisecond. So every 2 lines displayed, it'll wait a second, and every time it goes from on to off, it'll wait a second, right? So now this is really accurate now. So as you can see, just going back to the delay function, what we did, we kind of remarked all that stuff down. You know, this is all now remarked. We're not using any of the loop stuff. What we're saying is we're using the built-in function that says OCell delay, and we're telling it the duration there. So I know it's convoluted way, you can just say OSAL delay underneath here instead of saying delay and then this going back to the delay. Yes, you can, but I think when it comes to development and you have the decision to switch between SYSBIOS and normal BIOS or non-BIOS way, you can detect that and say, actually, I'm seeing SYSBIOS is not really started up yet. I'm going to do the loop stuff. And I think you can, if you wanted to do the loop and the for and stuff, it's inaccurate. I strongly advise against it. Not the right way of doing things. This is the right way. So you've got the SYSBIOS now, and you've got the stuff that actually works. So whilst we're doing this, let's just do a little tuning up. So rather than saying on and off, I'm just going to say 1, and 1 in here, and a 0 there. Just make the display consistent. Yeah. And yes, I can compile that in a minute. But yeah, I mean, if I wanted to speed that up, I can do speed up 100 milliseconds. Yeah, 100 milliseconds is nice. Delay 1 second and then 100. Let's delay for half a millisecond. And delay that for a second. Yeah, why not? So now you can see the timing now is absolutely spot on. Yeah. So now, because we already compiled and we didn't change anything on the SYSBIOS, you should just go fast and run straight away. But yeah, I mean, this is for you to understand what's behind SYSBIOS and how to get SYSBIOS to power up your stuff going forward. And I think this is really good. Well, hopefully, I think you might like it. A lot of people got lost and don't really know what SYSBIOS is. This is SYSBIOS now. So now you can see, as you can see on the lights on the board, so there, so ding, ding, see, on, wait half second, off, wait second, on, yeah, so see that? So we're switching on, waiting for half a second, we're switching off and then waiting for a second. So you can see the timing is really accurate. Now, this is, you can do this in Arduino, sure, yeah, whatever. But if I go back in here, and that's where things get more beautiful. So add. And I'm going to say LED toggle, and I'm going to say task LED toggle. Yeah, keep it simple, same thing all over the place, and save. Yeah, and I'm going to go back in here, and this time let's power up there. And so task 1 void task 2 and if I do let's just toggle one of the LEDs. So let's do a for loop to begin with. So for, yeah, that's an infinite loop, it'll not stop. And then I'm going to say GPIO toggle, and I am going to say pin number 2, pin number 1, why not? So that will toggle it. Whatever it was, it will toggle it and it will come back to, and this time I'm going to do delay for 50 milliseconds. Yeah. Now, and also what I'd like to do as well is yeah, let's do this. UIRT printf, and I'll just do a little dot there. Okay. So this will do a dot 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 dot, and then it'll keep toggling the thing. So the GPIO toggle means if it's here, if it's 1, put it back to 0. Sorry, if it's on, switch it off. If it's off, switch it on, and so on. And it'll wait for 50 milliseconds, which means 20th of a second, and then do this. So whatever this guy's doing, then the LED ripple, this will gonna be faster, and it's gonna have a nice effect. And I'm gonna run this now. I'll show you what happens. So this is the stuff that Arduino or a single-threaded system cannot really do for you. Arduinos are single-threaded; they can only do one stuff. This is where the fun begins. That's why you start mixing signals and mixing things together, and mixing threads to do the same thing. So let's just clear the screen on this one here, if we can. Yeah. Waiting for that to build, and it should carry on. We already have tasks, so it should be compiling soon with the cache. The next video, we will talk about the input side and how to read the switches. And I mean, to be honest with you, the video is 42 minutes down, and I'm thinking I can probably add the reading of the switch on this one, or maybe I should do it in the video after, because I will read the switch in two ways. I read it in polling mode, which means I just keep listening, waiting for something to happen, and then read, or I can read it in an interrupt mode. Yeah, so now we're linking, build finish. Yeah, we're waiting to deploy. Now you'll see, keep an eye on the LEDs. I'm just going to move it to this screen now. Actually, just keep it there for now, for a second. Once we deploy, you'll see, I'll change the screen in a minute. There we go. Beautiful. You see that? Yes. Now, just going to zoom onto this. Now, see on the serial port, you got one thread, one task doing stuff, the other task doing stuff in between, right? So if I go back into this display, see that now? We're still doing the switching on and off, but because of the toggle, it's kind of, you know, doing all four of them. In fact, you may not be seeing this much, but I think let's just add another effect. So let's just do 0, 1, 2, 3. These are all 3 pins in here. Yeah, let's toggle them at the same time. It'll display nicer. So what I've just done, just to show you what I've done here, I've just copied the function to 4 lines. So rather than toggle just pin 1, I'm just toggling 0, 1, 2, 3. So all 4 pins being toggled. That's all I did. And now back to this one, and you'll see the difference. Waiting for that to deploy. Linking. Delivery coming. Yes. And now you'll see the difference. Look at that. See, we're toggling the pins at the same time of writing the function. So I don't know if it by what you know I'm trying to do. So basically is we're doing on and then off, but because the toggle is so fast, it's kind of making them like flickering. And if I, oh, there we go, it's delivered. Hello mate, I'll have it. Cheers buddy. Sorry?
There's something damaged inside the box.
The van, yeah.
I just want to have a look if your stuff is fine.
We're fine, we're good. Thank you very much.
Thank you.
Cheers mate. Yeah. Sorry, delivery. Yes, okay, right. Yeah, so now you'll see if I kind of take that time down to 10 milliseconds, and I will we'll keep the same. So yeah, just run the same thing. You get the idea. What we're doing this interconnection. So we have one thread doing stuff, and you got another thread doing the other stuff, and they kind of, you know, fighting each other up. And this is where the beauty is. So when it comes to audio processing and audio development, that's exactly what we're going to do, or you'd like to do. So you have a DSP throwing stuff up, and another DSP kind of, you know, tweaking the signal to give it a different sound or a different shape or even different parameters to the sound. All that is going to happen with this. You know, this is how you're going to process it. So now let's see the difference. Yeah, it's too fast. I know you're probably getting bored of this, so let's just do 200, and that's the last thing we're going to carry on. Last thing, I promise. Yeah. I should see you rolling soon. Yeah, there we go. Looking forward to that. See that now? There's a difference. You see now? That's exactly what I wanted to show you initially. Of we having a signal going through the lights, but you have another signal kind of disrupting it, and yeah, so this is pretty much what we wanted to achieve today. And I think that's, I mean, we can conclude the video for now, but I think we'll if you like, we can touch on more stuff. Obviously, if you'd like to pass arguments to the function, you can say, for example number 1 or number 2, and then you would come back in here and says if argument 1 equals 1, then do this. If argument 1 is 2, then do the other bit. You know, some logic you can add. You know, these are tasks, and you know, you can do stuff with them. Other bits we haven't discussed, and I don't think we'll discuss in this video, but I'll show you just vaguely or just briefly. And you've got, for example, on the I/O, sorry, I'm not looking for that. Where is it? Yes. So on the scheduling, we have the HWI and the SWI, the hardware interrupts and the software interrupts. We'll cover that in the next chapter, next video. Sorry. But for now, I think now you see on the SYSBIOS side what the difference is, and now because you're using SYSBIOS, the clock inside is actually quite accurate and internal, and you're running multiple threads. So in an ideal world, you'll have a task kind of listening on you know, stuff, or sorry, a task generating, for example, pulses. For example, on a music instrument, you can ask it to generate an LED to say the tempo is at that speed. You know, I can you know, whenever you increase the tempo, it will, you tell it to do an interrupt, and the interrupt will change the timing, and the timing will it's a lot of things in the back that you can do, but you know, eventually this is the beginning of you know, the really a big world, to be honest with you. We're nowhere near the finishing off, and this is all the beginning. Eventually I intend to work on the audio side and create a really good instrument, hopefully at some point, and yeah, so this is my plan, and yeah, we'll take it from there. So again, like I said in the past, thank you for watching the videos, and really nice of you to spend some time. Share comments if you like. You know, I usually never said this, but if you like to like, share and subscribe. I've never ever said this before, but you know, it does help me a lot. Not that I really cared in the past on you know, anyone sharing or caring about my videos. It didn't really matter. I mean, I'm just doing this for educational purposes. If it does help you, then you can click the like button. If it doesn't, then nice to meet you, and have a nice day. Thank you very much. We'll see you later.